Okay, so we've been spending the first part of this semester getting you used to algebraic notation and the idea of what a term is and what are the four parts of a term and how to work with them. Well, today what we're going to do is we're going to look at begin our look at some equations. In other words, some problems that involve using terms. So we have to understand what a term is so we can learn how to manipulate them. So these are designed just to get you used to moving terms around and doing things with terms. Now, you've got to make sure that you remember that you already have some knowledge about how to do some things. Now, I'm not talking about just in mathematics. I'm just talking about your everyday life and how you do things, right? And so if you try to relate the new things to things that you already know, then you're going to be a lot happier with the results, okay? So keep in mind, just because we're doing mathematics, that doesn't mean it doesn't have anything to do with anything you've ever done in your life. And if you relate it to something you've already done, then you're more likely to have a better outcome, okay? You're more likely to memorize it or put it in your memory. So today what we're going to do is we're going to talk about solving linear equations. Now, we need to define what that means first, right? And what I wanted you to do, though, is the first thing I want you to do is I want you to know what it is we're doing. Too often you study something, and we know it's what I'm doing because that was the homework lesson for today, right? You don't know the name of it, and you don't know how to recognize it. So when it comes up again in another lesson, you're completely lost. Any of you ever done that? You've done all the homework. You did fine on the homework. You watched me do some problems on the board. Everything's good. You get the test. You look at it and you're going, I have never seen any of this crap before in my entire life. I do not know what he wants me to do. I have no idea. Okay? No clue. What's happened is that you focused on the problems, doing the homework. You focused on doing the math so much that you forgot to learn what it was you're doing, right? If I tell you to drive to the store, right, I've used that a million times, I know, but if I tell you to drive to the store, fine, go. What store? What do you want me to bring back? Could you drive to a store? Yeah. What are the chances it's going to be the right one? I don't know. But if you know specifically what it is you're going for, that narrows it down some, right? Right? If you're going for milk, you probably wouldn't go to Bell's. So, and then if you're going for, you see what I'm saying? So if you know what it is you're looking for, you're more likely to find it. So keep that idea as in your mind as you study for these. Don't just look at the directions for something. Don't just look at the problem and try to work it. Read your notes and know the name of the thing you're looking at, etc. So as we go, watch how I solve these. Because these are so easy if you'll just let them be. Okay? But if you won't see what they are and when to use them, then you're going to constantly have trouble with them. Okay? All right. So solving linear equations. Solving means to get the answer. Right? We'll talk about that in a little bit more. And these things are called linear equations. We've already talked about the word equations. How do you recognize something as an equation? What is it? Exactly. Anything is an equation as long as it has an equals symbol in it. And you can call it a sign. That's perfectly fine. I know that's probably how you learned it, but it's really a symbol. What are the signs? Positive or negative. But I guarantee every teacher you had probably taught you an equal sign. It's fine. All right, but it has an equal symbol. And we know that something is linear. Think about linear. What word is the base for linear? Line, yeah. These things are called linear because if you graph them, which you'll do later, you graph them, they just make a straight line. Okay? But we're not going to graph them in this particular section. We're going to be solving them. So we have to recognize them as linear. And we recognize them as linear because they have an exponent of 1 on the variable. So they have an exponent of 1 on the variable. Now, there's some things in there that we've already talked about, right? What's a variable? The letter. Good. The letter is a variable, right? Excuse me. And we said that every variable has an exponent, and even if it doesn't look like it has one. If it doesn't have an exponent, then what do you assume that exponent to be? A 1. Remember we looked at that? When everything has an exponent, but if it doesn't have an exponent written there, then you assume that exponent to be a 1. So in other words, these are going to look like they don't have any exponents. And a lot of people just say, I know it's linear because I don't see any exponents. Okay? Which is perfectly acceptable. But it really means that the exponent is a what? Is a 1. Excuse me. All right. So these are linear equations. So we know they're equations because they have a what in them? And we know they're linear because the highest exponent in them is a 1. In other words, it's going to look like there's no exponents at all. Okay? So what we want to do is, we want to look at how to solve these. But before we can do that, we first have to look at some things about cleaning them up. Because, think about it, if you're looking for your car keys, you don't want to dig through everything you own to find them, right? If they're right where they're supposed to be and everything's neat and orderly, you can go right to it, grab it, and go. Yeah? And that makes your life easier. If you have to dig through everything you own, you're going to get frustrated, and it's going to cause you to make mistakes. So we want to make sure that these things are cleaned up as well. There are a lot of things that we can do to get them ready to solve. And as a matter of fact, there are actually 3 steps common to all equations. Did I just tell you that you're going to see all 3 steps in every equation? No. I just told you that there are 3 steps common to all equations. That doesn't mean you're going to always do them, right? Okay? So, but you have to look for them every time. First, because these steps are not designed to solve the equation, they're designed to clean it up and get it ready to solve. So think about it. If they're designed to get it ready to solve, then you need to do them first, right, before you start trying to solve it. So always keep in mind that there are certain things you have to accomplish before you can get things done, right? If I want to go on a road trip, better make sure there's gas in the car, right? You better make sure the car starts. There are certain things you've got to do before you begin. The first of these steps is the same as the first step for the order of operations. What do you look for when you're doing the order of operations? What do you look for first? What? Parentheses. There you go. There you go. You're thinking of a term. Yeah, that's fine. It's perfect. So first you look to see if you have any parentheses. If you have any parentheses in your equation, then your first job is to get rid of them. By looking where first? Inside. Then you look for an exponent, which is not going to have, and then finally you look for the coefficient, which is the multiplier up front. Right? Which is one reason we've spent so much time talking about parentheses in this class. The second step is one that makes you very, very, very happy.
Fractions.
Clear fractions. When you're working with equations, you don't want to have any fractions in them because it makes your life harder. I know that fractions don't usually make your life harder, right? But in an equation, it does. So you're able to eliminate the fractions. And here's the good news. By all the stuff we've already done with fractions, you already know how to do this. We're just going to put it together in a different way. Now think, that makes perfect sense. You do that all the time with everything you do. You do mostly the same actions all the time. You ever get dressed? Yeah. Okay. Do you dress differently if you're going to the beach than if you're going to a wedding? Yeah. It's still the same stuff, the same steps. It's just applied a little differently, right? You do the same stuff over and over all the time, but you can do it in different ways to make it appropriate for a different situation. Okay? And that's what you're doing here. We're going to use the same stuff we already know about fractions, but this time we're going to use that information to eliminate the fractions. Okay? And the third step that's common to all equations is to combine any like terms that are on the same side. Of the equation. Now, we don't like to learn every word of every sentence. For some reason, when we're doing something, we only want to learn tell the meat of the story, right? We don't want to have to deal with every word. But that causes you trouble. Okay? So you make sure that you know what it is you're talking about, to yourself at least. Now, you can abbreviate, that's fine. But don't cheat yourself by not learning every part of the process. We're combining any like terms that are on the same side of the equation. Okay? Sorry, equation, plural, singular. Make sure that you're only looking on one side of the equation at a time at this point. We're not talking about going across that equal symbol. You have to think of that equal symbol as kind of a wall that separates the two sides of the equation. You're going to do one side, and then you're going to go over and do the other side. So don't be moving stuff across the equal symbol at this time. We will later, but not now. Right now we're just talking about cleaning up each individual side. Okay? All right. And these three steps are common to how many equations?
All of them.
All of them. You always look for them. Now today, you're only going to have parentheses and then probably some combining like terms. We're not going to be talking about clearing the fractions until next time. Because I want you to get used to the other steps first, the other processes first, and then we're going to concentrate on the fractions because I know how much y'all love them. Okay? So, now again, these three steps solve the equation? No, these three steps clean up the equation and get it ready to solve. So you go through these three steps to get it ready to solve. Then when you're ready to solve, the next thing you should ask is, what kind of equation is left? Because after you clean up the equation, you might turn something that's linear into something that's not linear anymore. Now, of course, in this class, all we're going to be looking at are linear equations, so you know the answer to this question. What are they going to be? Linear. And how do you recognize it as linear? You don't see any exponents, which means the highest exponent is a 1. So, in this class, they're again all going to be linear. And we know that because the highest exponent is a 1. In other words, it's going to look like there aren't any exponents at all. Because if the highest exponent is a 1, you don't even bother to write it. Remember we were talking about how important it is to know where you're going before you just get in the car and go? Well, you need to know what the goal is for solving an equation. I need to know what it's supposed to look like when I'm done. Right? Then that way I have a better chance of doing it, of getting there. Our goal, then, is to get the variable. What's a variable? The letter. Good. The variable completely. You've heard the word completely before, right? Completely by itself. So get the letter or the variable completely by itself. So would I be done if it said 4x equals something? No, the number has to be gone. You can't have anything with it. Would I be done if it says negative x equals something? Nope. We don't want a sign there either. We don't want anything to be there with our letter. So that's our goal. So that's what it looks like at the end. The letter is all by itself on one side of the equal symbol. Now the method we're going to use to solve this is also very simple. The goal is a very simple goal. Get the variable completely by itself. And the method we're going to use to do it is also a very simple idea. We're simply going to use the opposite operation. In other words, you're going to look at how things are put together and you're going to take them apart by doing the opposite. Makes perfect sense. If you were putting a screw into a hole, you'd turn the screwdriver one direction. What do you do to take it out? You turn it the opposite way, right? Equate it to stuff that you already know, and then you can see why you're doing what you're doing in the mathematics. So, if two things are connected with addition, or plus symbol, what's the opposite of add? Subtract. If two things are connected with subtraction, you would add them. Now, of course, we think of those pluses and minuses as signs, right, now. So if it's positive, you'll use some minus, subtract. If it's negative, you'll use positive or addition, right? So it's the sign that you look at those pluses and minuses. If two things are connected with multiplication, what's the opposite of multiply? Divide. So you'd take them apart by using division, right? If you can recognize the operation that's holding two things together, then you'll have no problem taking them apart. So what if you see a plus? What are you automatically going to do? No thought. Subtract. What if you see a minus? What are you going to do? Not thinking of it. Right. What if you see like 4x? What does 4x literally mean? Multiplication. So what are you going to use? Division. Right? Okay. So look at the operation that's holding things together and take them apart by doing the opposite. Make sense? That's all you have to do. Now, of course, you know me. I'm not going to leave it like that. I'm going to give it to you in a series of steps, right? Because you don't want to just jump in and start doing stuff. You want to take things in a neat, organized way. So let's talk about how you accomplish that goal. The first thing you want to do is get all variable terms. Now, we've talked about terms. The terms are the building blocks, right? And the first part of every term is its sign. So you can always tell when one term stops and the next one begins every time you see a plus or a minus, right? And what's a variable term? Term that has a what in it? A variable, any letter in it, right? X, Y, A, B, it doesn't make any difference. Any variable term, a variable term is simply a term that has a letter in it. So get all variable terms on one side. Now, when I say on one side, I mean on one side of the equal symbol or the other. And I don't care what kind of a little math Nazi you had in high school, it doesn't matter which side. Mrs. Alcorn. Every X had to be on the left-hand side. Do you know why your teacher did that to you? Because then they can just look down there and scan it. It makes it easier to grade. Well, tough. Exactly. I'm not here to make it easier on me. I wish. But you need to be flexible enough to know that if you have X equals 2 and 2 equals X, those two things mean the same thing, right? If X equals 2, what does that mean 2 equals? X, right? You should be able to go back either way. So it doesn't matter which side your X is on. Now, if you're one of those and you want it on the left-hand side all the time, that's perfectly fine with me. I don't care. But you're going to cause yourself more work than you need to go through in some problems. Okay? It doesn't matter which side your variable term moves to. Okay? Put it on the right, put it on the left, look at the problem and let it tell you which way to go. Now, there is one little bit of advice I can give you about it. We generally like to keep the variable term positive. Now think about how to get a positive. If you subtract a little number from a big number, then it stays positive, right? But what happens when I subtract a big number from a little number? That's how you get negatives, right? Okay? So you can keep the variable term positive by always moving the smaller one. If you move the smaller variable term, it'll always keep everything positive. Keep the variable term positive. Okay? So if you had 2x and 4x, which one would I move? 2x. Think of it like this. We're moving something, so we want to move the lighter one, the smaller one, right? If you were going to carry them physically, you'd want to move the smaller one, wouldn't you? Right? But be careful about it with signs. What if you have negative 7x and positive 2x? Which one of those is actually smaller? The negative. Remember, the negatives are always smaller, so you'd move the negative. Even though the number is bigger, it's more negative. It's smaller, so you'd move the negative 7. Because how would you move a minus 7? You would what? Add 7, right? The opposite of subtract 7 or minus 7 is add. So you'd add 7. So in other words, you're making it positive. Okay? All right. Now, again, it doesn't matter which side you go on, but get it one side or the other, and typically we want it to be positive just to make our lives easier. Now remember how terms are connected to each other? How can I tell where one term stops and the next one begins? What? The sign. So pluses and minuses. So that tells us that one term is connected to another term by addition or pluses and minuses, right? So that's how you're going to move them. You're either going to add or what? Subtract. Add if your term is what sign? Negative. Subtract if your term is what sign? Positive, right? Because you do the opposite of what you have. You just, whatever it is, you do the opposite of what you have. Once you get your variable terms on one side, and again, it doesn't matter which, your next step is to get all number terms. Now, if a variable term is a term that has a variable in it, what do you think a number term is? Just a number, right? No letter in it. It can't have a letter. Now, can a variable term have a number in it? Yes, you bet. It's called the coefficient. But a number term has to be just a plain number. Remember? Get all number terms on the other side. Get all number terms on the other side. So in other words, if your variable terms are going to the right, then your number terms have to go to the left. If your variable terms are going to the left, then your number terms have to go to the right. So you get the idea here? It's still the opposite operation. Basically, you're putting in the opposite directions. And you let your variable terms tell your number terms what to do. If your variable terms go that way, then your number terms have to go the other way. Okay? So always let the variable terms tell your number terms what to do. This is one of the big problems that students have when solving equations is they're not sure which thing to move where. Well, move your variable terms first, and whatever way your variable terms go, your number terms do what? The opposite. They go the other side. So that way you'll never have to even think about it anymore. Variable terms go to the right, number terms have to go to the left. Okay? Now again, these are whole terms I'm moving, and terms are connected with pluses and minuses, so we'll move them with pluses and minuses. You're either going to add or subtract. Add if it's negative, subtract if it's positive. Okay? And your third and last step. Divide both sides by the coefficient of the variable term. Divide both sides by the coefficient of the variable term. Why would I be dividing with a coefficient? Because what's another word for coefficient? Or coefficient is just a fancy word for a multiplier, right? And the opposite of multiply is divide. Okay? Now notice here that I said divide both sides. I need to clarify something about equations. You can do anything to an equation. Anything. You can add 7, you could divide by 2, you could multiply by -2/3. I don't care what you do. You can do anything you want to an equation. As long as you do it equally, which in other words means both sides. It's like a balance, right? Remember those old-fashioned scales with a balance? Now to keep them balanced, you have to have the same stuff on both sides. That's why they used to not even call them solving equations. It used to be known as balancing an equation. right? So if I took off some weight on this side, that's perfectly fine as long as I took off exactly the same amount of weight on that side of the scale, right? You have to keep it balanced. So if you add more weight to one side, you have to what? Add the same amount to the other side. Now don't think of it as doing the opposite to both sides, because that's not what's happening. If I add 7 to one side, that's fine as long as I also what? Add 7 to the other side, right? You have to do it to both sides equally. Okay? You're using the opposite of operation, but whatever you do to one side, you have to do it equally to the other side. So if I subtract 2 from one side, what? Subtract 2 from the other. So don't get confused about that. Okay? All right. Once you've done those 3 steps, the x will always be by itself, or y, or a, or whatever. They like to use lots of different letters here because they want you to get used to the fact that any variable term simply means any unknown, right? That's all those letters mean, or just some unknown number. Okay? Now we're going to start off slowly. They're not going to have any fractions in them. They will have parentheses, and they will have some like terms to combine. And they're going to be very simple equations at the beginning. And then we're going to build on that. So next time we see, we're going to build up, we're going to talk about what happens with the fractions. And you have to understand how equations work, and you have to be very comfortable solving equations, because equations are the whole point of algebra. There's no reason to learn algebra if you're not going to learn how to solve equations. That's what it's used for. So we're going to spend a good amount of time working on equations. And we're going to have some applications involving linear equations. In other words, word problems. And if you don't understand how the equations work, then you're not going to know how to set up the problem as an equation. So you've got to make sure you're really concentrating here. So study the notes as well. When we go up to lab, don't just concentrate on the homework. Look at your notes first, then do the problem, right? Or do that little trick I've been doing with the writing the steps down along the side of the problem. Whatever you need to do to make sure you remember every question to ask. Because the reason it looks easy when I'm doing it on the board is because I'm driving the questions. So if you can learn to ask yourself the right question at the right time, then you can do this as well. Okay? All right. We're going to start off really easy. Now we're going to go through the steps, even though I know most of you will already have the answer before I get the problem written on this one. The first thing you always need to know is what kind of thing it is. Because we've never solved equations before in this class, have we? We've worked with equations. We've seen if a number is a solution by plugging it in, but we've never solved an equation. So the first thing we need to know is, what kind of problem is this? And there's one thing up there that tells me that this is an equation. What thing is that? The equal symbol. If it has an equal symbol, then it tells you that this thing is an equation, right? So we go to our steps for solving equations, and it says that before we solve, there are 3 steps common to all equations. Those 3 steps are designed not to solve the equation, but to get it ready to solve. So you have to do them first. What's the first thing we always look for? Parentheses. Pretty much the same thing we do anytime, right? Anytime you see a problem, math thing, you do parentheses. But what do you notice here? Don't have any. What do we look for next? Clear any fractions, yeah. But what do you notice? Don't have any of those either. And then third, we look for like terms that are on the same side. Okay? Well, x and negative 3, are x and negative 3 like terms? No, because that's a variable term and that's a number term. Okay? And on the other side, all we have is the 9. Now, aren't negative 3 and positive 9 like terms? Yes. But I'm not going to combine them right now. Why? Because they're on opposite sides of the equal symbol. Exactly. Good. The only way I would combine them right now is if they were both on the same side of the equal symbol. Okay, so you see why, even though they're like terms, I'm not going to mess with them right now? Then, I need to ask myself, what kind of equation? What kind of equation is this? What is this called? Linear. How do I know it's linear?
No exponents greater than 1.
Yeah, you don't see any exponents, which indicates that the highest exponent on that variable is a 1, right? Okay, good. So our goal is to get that x completely by itself. And the method is to use the what? Opposite operation. So my first step is to get all variable terms on one side. How many variable terms does this equation have in it? Just one. Well, if it only has one, it's on one side, right? Okay. Then my second part is to get all the number terms on the other side. How many number terms do I have here? 2. There are 2 numbers in this one, right? 2 number terms. And so that means I know they're on opposite sides, because if they were on the same side, I would have put them together as into one when I combine my like terms, right? So I've got to move one of them. Well, which side is my x on? The left. So what does that tell me about my numbers? They need to go to the right. So do I want to move the negative 3 or the positive 9? The negative 3 needs to move to the right to be with the other number, right? And since it's a minus 3, what's the opposite of minus 3? Add 3. And I can add 3 all day long as I also add it to what? To both sides. Now let's do the math. The x just comes down, doesn't change. 3 minus 3 makes 0, but x plus 0 is the same as just plain old what? So, So do I need to write plus 0? No. That's the whole thing, the point of this. These opposites will always simply eliminate each other. Right? Now, don't forget your equal symbol. I cannot tell you how many times students have done beautiful work, but they lose the equal symbol, so they don't know where they are. And then they get the answer wrong. Okay? Make sure you don't forget to bring down your equal symbol. And on this side, 9 plus 3, of course, is 12. Is my x completely by itself? Then that's the definition of done. Once that x is by itself, you don't always have to go through every single step. So x in this case equals what number? 12. And literally what that means is that if you put that 12 right there in place of that x, then you'd make a true statement. Remember how we check to see if it's a solution in those other problems? What's 12 minus 3 make? Does 9 equal 9? So that's literally what it means. That if you replaced every x with a 12, it would make a true sentence. Okay? All right. Say I have the equation 12 plus x equals negative 2. I know that this thing is an equation. How? Has an equal symbol. Good. That's the definition of equation. It has an equal symbol, right? So we know it's an equation. There are certain steps common to all equations. How many? 3. And again, they're not designed to solve the equation. They're just designed to get it ready to solve. What do I look for first? Parentheses. But do you have any? Nope. What do you look for next? Fractions. Do you have any? Nope. But you always have to look for them because they will come back. Okay? And third, we look to see if we have any like terms that are on the same what? Side. On this side, I have 12 plus x. Are 12 and x like terms? Nope. On this side, all I have is a negative 2. It's all by itself. Now, the 12 and the negative 2 are like terms, but am I going to mess with them right now? Why not? Because they're not on the same side. There you go. Good. Okay? Now, then, what I need to do then is I need to know what kind of equation it is. How do I know what kind? It's linear because you don't see any exponents, which indicates that the highest exponent is a 1. You need to know that piece of information. Not just know they're all linear because that's all we're doing in this class, right? You need to know it because when you move up to intermediate algebra, which is your next class, if you don't know it, then you're going to be in trouble because you're going to add more types of equations. Then you get to college algebra, and college algebra is the study of equations. There'll be about 5 or 6 types of equations. So if you don't know what kind they are, you're not going to know how to deal with it. And so you need to learn or train yourself to ask yourself what kind from the very beginning.
So do you teach algebra classes also?
Oh boy, yeah.
You do?
Oh yeah.
Okay.
So what kind of equation is this? Linear. Good. So my goal is to get the variable completely by itself by doing the opposite operation. The first thing I need to move are the what? variable terms. But how many variable terms do I have in this one? So is it moving? No. Then I need to move the number terms. How many number terms do I have? 2. So one of them wants to move. Now my x term is on which side of the equation? So that means my numbers have to go to the right. And so which number needs to move? The 12. And it doesn't have a plus or a minus in front of it, but we know that that means it's really a plus in front of it, right? So what I have here is a plus 12. So how do you move plus 12? Subtract 12. So if it doesn't have a sign, you know that sign means a positive. Now let's do the math. The 12s will subtract away from this side, leaving me just plain old what? X. And I don't need the plus in front of it since it's all by itself now, right? And then over here, negative 2 minus 12 will combine to make what?
Minus 14.
Good. The signs are the same, so you keep the sign and add the numbers. Is my x completely by itself? So there's my solution. Now, in Course Compass, all they want you to type in is the negative 14. Okay? Don't type in x equals negative 14. They don't want that part. They just want the number itself. But do make sure you include the sign or it'll be wrong. Okay? All right. Now, look at this one. Now, I know that these equations are very simplistic. And the reason for that is I'm trying to teach you from scratch. I could give you much more complicated equations if you want them. But did you learn to spell by learning to spell anti-disestablishmentarianism? Probably not. Most of you probably couldn't spell it today. But you learned to spell small words, and that led you to be able to go on to more complex things, right? So you don't want the hardest thing the first day. But you also don't want to cheat yourself and not walk yourself through every step of the way. Pretend like you're spelling words the very first time you ever spelled words, right? You had to walk yourself through the process. So I'm giving you these simple problems so that you can concentrate on the notes. Not just to make it so you have some of them you can get right. Yeah? I want you to concentrate on the method. So walk yourself through every step, even though most of them don't exist in these problems, right? Because your whole goal here is to learn the process. First of all, we know that this is what kind of problem? An equation. How do you know it's an equation? The equal symbol. Okay? There are certain steps common to all equations. How many? 3. What do I look for first? Parentheses. Do you have any? Nope. What do you look for next?
Clear fractions.
Do you have any of those? Nope. Third, you look to see if you have any like terms that are on the same side. Do I hear?
Yes.
Oh, be careful. Are these on the same side?
No.
No. See, I have 2 x terms, but they're not on the same side of the equal symbol, right? That one's on this side, that one's on that side. Okay? Okay. So, didn't have to clean it up. What kind of equation is it? How do you know it's linear? No, yeah, there's no exponent, which indicates the highest exponent is a 1. So the first thing I need to do is get all my variable terms on one side. How many variable terms do I have here? That tells me that they're not on the same side, right? Because if they were, I already would have combined them into 1. Now, I've got to move one of those variable terms. Do I want to move the 5x's or the 4x's? Yeah, always move the smaller one. It'll keep things positive. Now, there's no sign in front of the 4x, but what does that tell you it is? Positive. So how do I move a positive 4x? I'm going to subtract 4x from where? Both sides. Okay? Now over here, 5x's minus 4x's makes what? 1x, and 1x, of course, is just plain old, is just plain old x. You don't want to leave the 1 in your answer, right? Remember, 1x is just the same as plain old x. You don't want to leave the 1 in your answer. Now, over here, the 4x's are opposite, so they're just going to subtract away. The temptation is to say 4x minus 4x leaves an x. Don't do that. Think of it like money. If you have $5 and I take your $5, you have nothing, right? Not $0. Does that make any sense to say $0? How many dollars do you have? 0. No, you just say I don't have any. Right? So get used to it. Anything minus itself makes nothing. 0. What is it? What does that leave me on this side, though? Is my x completely by itself? So that, well, be careful, isn't it? Yeah, it's all by itself. So therefore, you're done. You didn't have to move any numbers or divide.
I didn't get it.
Okay? Didn't get what?
So how it's gonna be if there's 5x and 4x?
Well, 5 of them, if you take away 4 of them, how many is left?
1.
1x. And 1x is the same as just plain old x.
And 4x plus 4x minus 4x are
They're opposite, so they subtract away, right?
they're going.
So they're gone. 4x's minus 4x's makes none. Nothing.
So why did
Okay.
you choose 4x?
Because I wanted to keep it positive, so I always choose the smaller one.
Oh, then you have to choose always
The smaller one, yeah.
So there's, let's say,
So if you had 8 and 7, which one would you choose? 7.
so let's say for instead of 5, there is 3 equals 9x.
Right. Then you'd move the 3 to the other side. Mhm.
So the 3. Okay.
Now, all right. We'll look at an example of that so you can see what I'm saying. Let's look at this one. Negative 8y plus 1 equals negative 9y plus 7. I know that this thing is an equation because of the what? Equal symbol. And there are certain steps common to all equations. How many? 3. What do I look for first? Do you have any? What are you looking for next? Do you have any? Then you look to see if there are any like terms that are on the what? Okay. Over here, negative 8y and 1. Are those like terms? Nope. Over here, negative 9y and positive 7. Are those like terms? Nope. So there aren't any like terms that are on the same side, right? Then I need to know what kind of equation it is. And this one is what? Because you don't see any exponents. So the first thing I want to do is get all my variable terms on one side. How many variable terms do I have in this equation? 2. So that tells me one of them needs to move. Now I can either move negative 8y's or negative 9y's. Which one do I want to move? Yeah, negative 9 is actually the smaller one. Why is it smaller? Because they're negative, right? If it's negative, the bigger the number it is, actually the smaller it is. So how do I move a negative 9y? I'm going to add 9y to where? Both sides. Good. When you do the math, what's negative 8y's plus 9y's going to leave you with? 1y, which is the same as just plain old y. Oops. Okay. Bring down your positive 1. Over here, the 9y's are opposites, so they simply subtract away. Yeah, opposites always will just eliminate each other. What does that leave me with on that side? Positive 7. Now that I have my variable terms on one side, I need to move my number terms on the other. So my variable terms went to the which side? To the left. So my numbers need to go to the right. So which one of those numbers needs to move? Positive 1. And how do I move plus 1? We'll subtract 1 from where? Both sides. The 1's will subtract away. It's just the plain old y over here. What's positive 7 minus 1 going to leave? Positive 6. Is the y completely by itself? Then you're done.
Why you choose 9 equals 8?
Because negative 8 and negative 9, because they're negative, this one's actually the smaller one. Now what if it was positive 8 and positive 9? Which one's the smaller one? The 8, right? So what you have to watch the sign. When you're looking at them, you not only watch the number, but you also have to look at the
And you get
sign.
1 because it's the smallest.
Right. 9 minus 8 just leaves 1.
So if there's 2 terms, then you have to make it 2, right? So it's like, I got it.
So you move, yeah. Okay? All right. Now, let's look at another one. 8x plus 3 plus 4x plus 8 equals 11x plus 3. So we need a whole different bunch of rules now because this one looks different, don't we?
No.
Do you ever need different rules to do the same type of problem? No. As long as you learn every step of the way, you never have to do that. Now, if all you ever learn are shortcuts, then you have to have a new rule for every problem. So, do you want to learn the shortcuts or do you want to just learn the one way that's good for everything? Okay? I know you get tired of asking yourself questions that aren't there, but it'll pay off. Trust me. So what kind of problem is it? An equation. You can tell that because of the equal symbol. Good. So, there are certain steps to all equations. How many? 3. What do I look for first? Parentheses. Do you have any? Nope. What do you look for next? Do you have any? Nope. What do you look for next? Like terms on the same side. Excellent. Do you have any like terms on this side? Yeah, we do, don't we? 8x's and 4x's are like terms, aren't they? Now be careful here. This is another place where students make huge mistakes. If they're already on the same side, then all I'm going to do is use the signs they already have and put them together. I'm not doing the opposite because I'm not moving them across that equal symbol. The opposite is what I do when I move them, right? So, what's 8x's plus 4x's going to make? Right. So it's not going to be 8x's and then subtract the 4x. Why wouldn't I subtract the 4x from it? Because they're both positive and they're on the same side. All I'm doing here is combining them, not moving them. So you're not doing the opposite. You just do whatever it tells you to do. Also on this side, I have positive 3 plus 8. What is that going to make? Positive 11. Thank you so much for that sign. Why do I have to have that sign?
Because they're both positive.
Well, because I need to separate them, right? Because it's two distinct terms. And if you just stuck 11 after that, it wouldn't mean plus 11, it would mean times 11, right? So be careful. Equals, now on this side, are 11x and 3 like terms? No, so they just come down. Now that I've got it cleaned up, I need to know what kind it is. What kind of equation is this? Because there aren't any exponents, right? So, first I want to move all my variable terms to one side. How many variable terms do I have? 2. So do I want to move the 12x or the 11x?
11x.
Yeah, and it doesn't have a sign in front of it, but if it did, it would be a what? Plus. So how do I move positive 11x? I'll subtract it from where? Both sides. When you do the math, what's 12x's minus 11x's going to make? 1x, which I, of course, am just going to write as plain old x. I don't really need the 1 in front. It's assumed to be there. Plus what? Now over here, the 11x's are opposites, so they're simply going to subtract away. What's that leave me with on this side? Positive 3. Now, and since it's all by itself, do I need the plus? No. But would it be wrong if I left it? No, right? If you want to write it, be my guest. Then the second thing, I want to get all my number terms on the other side. How many number terms do I have up here? 2. So one of them needs to move. The smaller one? No, you don't worry about that with numbers. That's only with variable terms. Which one do I move? Yeah, I want to move the one that's over with the x because I want to get it away from the x. And how do I move plus 11? From where? Leaves my x by itself alone because the 11s will subtract away. And over here, what's 3 minus 11 make? Minus 8, or negative 8. Good. Is the x by itself? Then you're done.
All right, Mr. Silver, I got a question.
Sir, you bet. I hope I have an answer.
Second step on the equation.
Moving the number terms?
Yeah, if you would have moved the 12x. instead-
Oh, I see. So that's moving the variable term?
Yeah,
Yeah, you could still get exactly the same answer. Let me show you what he's saying. Okay, watch. If you move the 12x's, it's positive, so you'd have to subtract it. That'll subtract away, get 11. 11x's minus 12x's doesn't give you 1x. What does it give you? Negative 1x plus 3. You see that? Now, we still don't have to write the 1 if you don't want to. You just write that as negative x. So that's still fine. which means that my numbers would have to go the opposite way, so the 3 would go that way. What's 11 minus 3? And that equals negative x, and those 3's would go away. But is my x completely by itself? No. But this is a great time to show you something. Okay? What's the only thing with the x?
Negative.
Well, I don't want it negative. I want it. Okay? Well, even better. Watch. What does that say?
You can do anything.
So if I don't like the sign I have, what? Change it. But if I change the sign on one side, to change it on the other. So don't even think about having to do any math here. If it's negative, you don't want it to be negative, change it to a positive. But if I change that sign to a positive, what happens to my 8? And you end up with x equals negative 8. Isn't that what we got a while ago? That's why technically it doesn't make any difference which side you move the variables on. Because if you get the wrong sign, what? Change it. And the thing that makes that possible is right there, that equal symbol. Now, we couldn't do that when they were expressions. We had to be really careful to keep every sign we had, right? Why can I do it now? Because this is not an expression, but an equation. And that equal symbol is kind of like a blank check. You can do anything you want to, as long as you do it equally. Okay? Good question. Thank you for that one. All right. Let's look at one more of these little ones, and then we're going to move on and look at some others. Say we have 2 times b plus 4 minus 9 plus b equals negative 2. Now this thing is still an equation. How do I know that? Because we have an equal symbol. There you go. So we have the equal symbol. That tells us it's an equation. There are certain steps common to all equations. How many? 3. Okay. What's the first thing I look for? And what do you notice? We've got them. So we're going to start by underlining the parentheses, where they start. And everything that's not part of a parentheses, I'm just going to bring down. Then I'm going to go back and deal with the parentheses. Now, I know you don't have to underline these parentheses and bring everything else down. Some of you can get the right answer. But I graded your tests. Most of you who didn't underline the parentheses and bring everything else down got them wrong. So, let's see. Get it wrong by not doing it. Get it right by doing it. You decide. Look where first? So b plus 4, are those like terms? Is there an exponent? What's the coefficient? So that means multiply everything inside by 2, right? What's 2 times b make? Good. Positive times positive is positive. What's 2 times 4 make? 8. Look inside the next one. 9 plus b. Are they like terms? Is there an exponent? Well, no exponent. What's the coefficient, though? Just a negative. Well, multiplying by a negative is not going to change the numbers, but it will change the signs. So my positive 9 becomes a, and my positive b becomes a negative b. Right? Remember, multiplying by negative doesn't change the numbers, but it does change the sign. After parentheses, what do I look for next? Fractions? Do you have any? Nope. What next? Do I have any like terms on the same side? Yeah, here I have 2b's minus b. Now, literally, that means minus 1b, right? And some people like to put in the ones when they're working on it, and that's perfectly fine. But do you want to leave the ones in your answer? No. What's 2b's minus 1b going to leave you? 1b, or just plain old b. Yeah, there you go. Okay? Now, these numbers are also like terms. So what's positive 8 minus 9 going to make? Negative 1. Good. Now remember, they're on the same side, so you just use the signs they have. You're not going to change the signs because you're not moving across the equal symbol. On this side, negative 2 is just going to come down because there's nothing else on that side, right? It's a linear equation. I can tell that because you don't see any exponents. How many variable terms do I have? So is it moving? How many number terms do I have? So one of them moves. Which one? Ooh, be careful. Yeah, I want to leave this b by itself, so I need to move the one that's with the b, right? If the b's on the left, the numbers go to the right. Okay? Most common mistake for equations, by the way. The b stays the same, the 1's subtract away, and what's negative 2 plus 1? Is the b by itself? Then you're done. Aren't you excited? Now, hold on just a minute because I have to preview and remove some stupid problems off of the next section of this homework before I can do these. And if I don't do it right now, I'm going to leave them and then y'all are gonna, it's going to mess with you. Truly stupid problems.
What chapters is this found in?
Chapter 10.
Why not they still use the way I explained it?
Because I ask you the questions.
I don't know.
If you know what questions to ask, then it's very easy. Okay, we're not done with some examples though. I want to do a couple of these before we leave, so don't pack up. I just want to get rid of some stuff that I hate about this assignment. Okay. Okay. There, now it's good. All right. Now, look at this one. Now we know that this is an equation. How?
Equal symbol.
So, are there any parentheses? Fractions? Any like terms that are on the same side? No. What kind of equation is it? Linear, because you don't see any exponents. Good. See this questions? No change at all to the list of questions. No exponent. Right? So the exponent right here. Okay? All right. It's 9x. 9x equals 63. Sorry, my handwriting. It's not me, it's the stupid pen. All right, then. So now it's linear. So first I want to get all my variable terms on one side. But how many variable terms do I have? So is it moving? No point if there's only one of them. How many number terms do I have? But what's this? Isn't that a number? Right. That's the coefficient of the x. Be careful. It's not a number, it's a coefficient. Okay? So, one number term, so it's not moving. But is the x by itself? What's over there with that x? And how is 9 connected to that x? And it's the coefficient, which means the multiplier, so they're connected with multiplication. So what's the opposite of multiply? So I'll divide both sides by what? 9. Not negative 9. I'll divide by the coefficient. So the 9s are going to divide away. What are they really making? A 1, but do I need to write the 1 in front of the x? No. Equals, now do this side, 63 divided by 9 is, now is the x by itself? So you're done. Okay? So, look at how things are put together and take them apart by doing the opposites. Look at this one. This one always causes trouble. There aren't any parentheses, blah, 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 blah. Variable terms, how many variable terms? 1. So is it moving? How many number terms? 1. 0 is a number, right? So is it moving? No. Is the m by itself? It's connected to that 12 with what operation? And so we'll take it apart using what? So we'll divide both sides by what? Positive 12. Be careful. Divide by the number in front, right? The 12s will divide away. What does that leave me with on that side? 1m, which is a plain old m. But what is 0 divided by 12? Yes. 0 divided by anything always makes what? So are you going to write 12 on your test? Some of you might. Don't! Be careful. That's a really common mistake. You've got to be careful. Okay? Now, the only other thing that can happen is that you might have like terms. Otherwise, the steps don't change. Okay?